According to NEC 210.6 D1, luminaires or fixtures for outdoor areas shall not be supplied by circuits exceeding 300 volts between conductors unless such luminaires or fixtures are mounted at a height of at least 18 feet above finished grade. Based on the NEC, 480-volt parking lot lights are not permitted on 18-foot tall poles because the voltage to ground, which is 277 volts, exceeds 300 volts. The purpose of 210.6 D1 is to reduce the risk of electrical shock or electrocution for individuals who may come into contact with the lights or their wiring. Higher voltages are more dangerous and can travel farther through the air, increasing the risk of shock. The highest voltage typically available for most pole lights is 480 volts, which is used for commercial and industrial applications. However, 480-volt lights may not be suitable for all pole heights due to safety concerns. There is an exception to this rule. 480-volt lights may be used on poles less than 18 feet tall if they are installed on a grounded Y system where the voltage to ground does not exceed 277 volts, or protected by a step-down transformer that reduces the voltage to 277 volts or less. To understand this better, let's delve into the NEC requirements and some electrical principles. Firstly, NEC 210.6 covers branch circuit voltage limitations. It focuses on ensuring safety by restricting voltage levels in various applications. Specifically, 210.6 D addresses voltage limitations for luminaires. 210.6 D1 is specifically for outdoor luminaires. It states that outdoor luminaires should not be supplied by circuits exceeding 300 volts between conductors unless they are mounted at a height of at least 18 feet above finished grade. This regulation is in place to mitigate the risk of electrical shock. Secondly, the voltage to ground is a critical concept. In a 480-volt grounded Y system, the voltage between any phase conductor and the grounded neutral is 277 volts. This is calculated by dividing the phase-to-phase voltage, which is 480 volts, by the square root of 3, which is approximately 1.732. Therefore, 480 volts divided by 1.732 equals approximately 277 volts. The NEC sets a 300-volt limit as a safety threshold for accessible luminaires. Thirdly, why is there a height requirement? The 18-foot minimum height is intended to keep higher voltage luminaires out of reach of the general public. This reduces the likelihood of accidental contact and potential electrical shock. Now let's talk about why 480-volt lights on 18-foot poles are generally not allowed. The key issue is the voltage to ground. Even though the luminaires are mounted at 18 feet, the voltage to ground in a 480-volt system is 277 volts, which is less than 300 volts. However, NEC 210.6 D1 restricts the voltage between conductors to 300 volts unless the 18-foot mounting height is met. Since the voltage between conductors in a 480-volt system is 480 volts, and the voltage to ground is 277 volts, it does not meet the exception of lower voltages to ground. This is why 480-volt systems typically require a greater mounting height than 18 feet. Let's consider exceptions. The NEC does allow for some exceptions. If the 480-volt system is configured such that the voltage to ground does not exceed 277 volts, the 18-foot mounting height might be acceptable. This can be achieved through specific grounding configurations or by using a step-down transformer to reduce the voltage to 277 volts or less. A step-down transformer reduces the 480-volt supply to a low voltage, ensuring compliance with the NEC voltage limitations. The specific wording of 210.6 D1 aims to prevent scenarios where higher voltage luminaires are easily accessible. By limiting the voltage between conductors or requiring a minimum mounting height, the NEC reduces the risk of electrical accidents. If the 480-volt lights are not on a grounded Y system, for instance, if they are on a delta system, the voltage to ground would not be 277 volts. In a delta system, the voltage to ground is more complex and depends on whether the system is grounded at one corner, center tapped, or ungrounded. In an ungrounded delta system, there is no intentional connection to ground, which makes fault detection challenging. In a corner-grounded delta system, one phase is directly connected to ground, resulting in a voltage to ground of 0 volts for that phase and 480 volts for the other two phases. In a center-tapped delta system, one phase is center-tapped and grounded, resulting in two voltages to ground, typically 240 volts each. If the 480-volt lights are on a delta system, careful consideration must be given to the grounding configuration and the resulting voltage to ground to ensure compliance with NEC 210.6. D1. If the voltage to ground exceeds 300 volts, the 18-foot mounting height is not sufficient. Now let's talk about grounding. Grounding is a critical safety measure in electrical systems. Grounding ensures that non-current carrying metal parts of electrical equipment are connected to ground, providing a low impedance path for fault current. This helps to quickly trip over current protection devices, such as circuit breakers, in the event of a ground fault, minimizing the risk of electrical shock. In a grounded Y system, the neutral point of the transformer or generator is connected to ground, providing a stable reference point for voltage and facilitating the operation of overcurrent protection devices. In contrast, ungrounded systems do not have a direct connection to ground, which can make fault detection more challenging. Ground fault protection is crucial for personnel safety and equipment protection. Ground fault circuit interrupters, or GFCIs, are designed to detect even small amounts of current leakage to ground and quickly interrupt the circuit, preventing electrical shock. Ground fault protection of equipment, or GFP, is used to protect equipment from damage due to ground faults by detecting and interrupting ground fault currents before they reach dangerous levels. The NEC has specific requirements for ground fault protection in various applications, including services, feeders, and equipment. It's worth mentioning other sections of the NEC related to outdoor lighting. NEC 410 covers requirements for luminaires, lamp holders, and lamps. NEC 410 addresses the installation, support, and wiring of luminaires. It also includes requirements for specific types of luminaires, such as recessed luminaires, track lighting, and electric discharge lighting. NEC 600 covers electric signs and outline lighting. NEC 600 addresses the installation and wiring of electric signs and outline lighting systems. It includes requirements for disconnecting means, overcurrent protection, and grounding. NEC 700 covers emergency systems. NEC 700 addresses the installation and operation of emergency electrical systems, which are designed to provide power and lighting during power outages or other emergencies. Emergency systems are critical for life safety in buildings and facilities. Remember that local codes and regulations may have additional requirements beyond the NEC. Always consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. It's also important to consider the specific environmental conditions when designing and installing outdoor lighting systems. Factors such as temperature, humidity, and exposure to corrosive substances can affect the performance and lifespan of electrical equipment. Use appropriate enclosures and materials to protect electrical equipment from the elements. Regular maintenance and inspection of outdoor lighting systems are essential for ensuring their safe and reliable operation. Check for damaged or corroded components, loose connections, and proper grounding. Repair or replace any defective equipment promptly. Be aware of energy efficiency. Use energy-efficient lighting technologies, such as LED luminaires, to reduce energy consumption and lower operating costs. Consider using lighting controls, such as photocells and timers, to automatically turn lights on and off based on ambient light levels or time of day. This can further reduce energy consumption and extend the lifespan of the luminaires. When selecting luminaires for outdoor lighting applications, choose products that are specifically designed for outdoor use and are listed by a recognized testing laboratory, such as Underwriters Laboratories, or ALL. Look for luminaires that are rated for the appropriate environmental conditions, such as wet or damp locations. Proper wiring methods are critical for ensuring the safe and reliable operation of outdoor lighting systems. Use appropriate wiring methods, such as rigid metal conduit, electrical metallic tubing, or liquid-type flexible metal conduit to protect conductors from physical damage and environmental conditions. Ensure that all wiring connections are made properly and are protected from moisture and corrosion. Use weatherproof boxes and fittings for all outdoor electrical connections. Proper overcurrent protection is essential for protecting electrical circuits and equipment from damage due to overloads and short circuits. Use circuit breakers or fuses of the appropriate size and rating to protect each circuit. Ensure that all overcurrent protection devices are properly labeled and readily accessible. Safe work practices are paramount when working with electrical systems. Always de-energize electrical circuits before working on them. Use appropriate personal protective equipment, such as rubber gloves and safety glasses. Follow lockout/tagout procedures to prevent accidental energization of circuits. It's important to stay up to date in the latest edition of the NEC and any applicable local codes and regulations. The NEC is updated every 3 years, and changes are made to address new technologies, safety concerns, and industry best practices. Attend continuing education courses and seminars to stay informed about changes to the NEC and other relevant topics. Consider the impact of outdoor lighting on the surrounding environment. Minimize light pollution by using shielded luminaires that direct light downward and prevent it from spilling into the night sky. Use lighting controls to reduce light levels during periods of low activity. Choose luminaires with appropriate color temperatures to minimize the impact on wildlife and vegetation. Remember that safety is always the top priority when working with electrical systems. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Proper planning and design are essential for creating safe and effective outdoor lighting systems. Consider the specific needs of the application, the environmental conditions, and the applicable codes and regulations. Work with qualified professionals to develop a lighting plan that meets your needs and ensures safety and compliance. Remember, while 480-volt systems can be used for outdoor lighting, careful attention to the NEC requirements, grounding configurations, and mounting heights is essential to ensure safety. Consulting with a qualified electrical engineer or inspector is always recommended to ensure compliance with all applicable codes and regulations.